Hello guys. So today we're going to talk about 3.1, which is all about quadratic functions and modeling. Unit 3 is all about polynomials, rational expressions, how to sketch them and everything. So first we got to look at a simpler polynomial, degree 2. So the highest exponent will be 2 in particular. Alright, so an example I'll give you is f of x equals x squared plus 1. The highest exponent here is 2. So there are three types of forms we can write a quadratic functions. When I say forms, it's similar to how you can dress. Everybody can dress differently. There are different forms in how you dress, but you are still that same person at the end of the day. It's just you have a different representation. So the first form is called the general form. We call this the general form because this is what the expression looks generally. Ax squared plus bx plus c. You have your degree 2, degree 1, degree 0, 3 terms in total. All right. The reason why we use this is because it's very easy to graph on your graphing calculator. And then another thing is it's very easy to find the y-intercept. Plug in 0 for the x and you automatically get your y-intercept. Very straightforward there. It's going to be that c value in particular because these will cancel out. 0 times any number is 0. So it's just the y-intercept here is c. All right. The next form is the really powerful form that we will use. It's called the standard slash vertex form. All right. We call it standard form, but times have changed over the years of mathematics. So I like to call it the vertex form because that's more universal. It's more clear to understand what I mean by vertex form. So this is f of x. Your a value is the exact same a over here, by the way. That a times x minus h squared plus k. This is easy to calculate the vertex or locate it, and it's easy to determine if your quadratic function will have a maximum value or a minimum value. And then we have factored form. This is if you're able to factor your expression. If you're able to factor it, we can easily see or write this as a product of factors. X plus something times x plus something. It can be plus or minus, by the way. This is easy to find the x-intercept, and it's easy to see the behaviors at the very end and the behaviors at the x-intercepts. All these forms are going to be very important. Right now, we're going to zoom into vertex form. We're going to later on talk about factor form, but right now, vertex form. So, standard form slash vertex form. And all of these have degree 2, by the way. Even if this doesn't look like it has degree 2, if you expand it out, it will have degree 2. So you have to be careful on that. So, let's take a look at vertex form. F of x equals a times x minus h squared plus k. I put these in pink and red. That way you know these are the values you will be changing. These are the constants. You do not have you're not going to use an x value or f of x value. You just need to change these for a function in particular. So what does it tell us? It tells us that the vertex is located at positive h and positive k. Now, h could be negative, k could be negative. It all depends. But notice this says minus h and this says positive h. That means you got to swap the signs to get your h value. Your k value will stay the same. So now, if your a value, if this value right here that you're multiplying by is positive, you will have a minimum. If it's negative, you will have a maximum. Now, I didn't say local minimum. I didn't say local maximum. This is actually just the maximum and minimum because there's no other, I guess, peaks that we have. So this is the lowest value, the highest value, period. You cannot get a higher or lower value than this. You cannot get a higher value than that, all right? We don't treat infinities as values. So that's very important, all right? And if you look here, if the a is negative, you can also see this in transformations. This is just a reflection across the x-axis. So we reflect this, boom, and that's why we have a maximum. Let's take this example. F of x equals negative 2 times x minus 3 squared plus 4. All right, this is in standard form. Well, the vertex is located, well, this is minus 3. I have to change the sign, so now it's positive 3. This is 4. I keep the exact same sign as 4. All right, and then you could say it has a maximum because this multiplication is negative of 4. How did I get 4? Well, it's this piece right here. The y value here is your maximum value. The output value is your max. All right, now we can treat this as transformations. And if I ever ask you for a transformation on a quadratic, I do expect you to complete the square or put it in vertex form. All right. So you can treat it as a reflection across the x-axis. You're moving right 3, which is why you have positive 3, and you're going up 4, which is why it's positive 4. So that's how you can view it in transformations. This 2 represents the vertical stretch of 2, if you will. So, going back, what happens if I ask you for the vertex, but I give you the general form? I don't give you the vertex form. Well, then you only have 2 options, really. You can either, well, there's a third option, graphing calculator, but I'm going to view down to 2 options. Completing the square, that's one of them, or use part of completing the square. So what later on mathematicians realized that students really struggle with completing the square. So thankfully, they said, hey, just use the important part of completing the square if you struggle with completing the square. So they formalize completing the square. And that's also where the quadratic formula came from, by the way. It's because students struggle with completing the square. So let's take f of x equals x squared minus 7x plus 3. If I wanted to complete the square, this is the b term. I'm going to divide that by 2. Boom. Divide that by 2. And I got to square this value right here and subtract that missing piece. This is the missing piece in my rectangle that turned into a square. So boom, minus 7/2 square. And if I simplify this, this negative is outside, by the way. It's always going to be subtracting that. So 7/2 squared is 49 over 4. Put the negative there. That's minus 49 over 4. Plus 3. I turned 3 into a fraction, least common denominator. I multiplied 3 times 4, which is 12 over 4. Boom. And then I can combine like terms. So now, this right here, this a value is actually 1. If you don't see an a value, assume it is 1. All right? So we have a vertex at positive 7/2, because this is negative, positive 7/2, comma, negative 37 over 4. We have a minimum value, because this is a positive multiplication, a minimum value of negative 37 over 4. Remember, this guy right here is your output or your max or minimum slash maximum value. All right? So what is the formula for completing the square? Part of it that we will take advantage of. Well, if you struggle with completing the square, you can always find the maximum or minimum value by doing f of negative b over 2a. So the input, the x value, is negative b over 2a. The output is putting this inside your function, throwing this as your input to get an output. All right? And we see b over 2. We divide the b term by 2, but we also multiply by, or divide it by a as well, if there is an a value. So I'm going to use the exact same values here. This is technically an a value of 1, a b value of negative 7. If I did that, boom, I get negative of negative 7 divided by 2 times 1, because a value is 1. Boom, I get f of 7/2. Well, notice f of 7/2, that's exactly the x value for the vertex. That's the h value. Now, if I throw in the h value into my function, into this function right here, then I get f of 7/2 is equal to 7/2 squared minus 7 times 7/2 plus 3. It better give me that y value of the vertex, or the k value. All right, so this is another way you can get that k value, or the maximum slash minimum, is by plugging in the x value into your function. If you complete the square, it is already here. If you complete the square. If you choose to do the formula for pieces of completing the square, then you will have to calculate the output. All right, because negative b over 2a is my input for my vertex. So that means the function of that input is going to be the y value for my vertex. Let's take another example. This time I have an a value bigger than 1. 2x squared minus 12x plus 13. Well, mathematicians don't like to work with new problems, so they always try to relate new problems with old problems. This has a 2. I don't like that. I like it if it was a coefficient of 1. So what I'm going to do is I'm going to factor out a 2. If I factor out a 2, only factor out a 2, I get x squared minus 6x. Divide this by 2, divide this by 2, boom. Plus 13. I'm not going to mess with this guy. Now, this is a guy right here I can complete the square with, because it has a coefficient of 1, the leading term. Right? So I can divide negative 6 by 2. I get negative 3. Now, the pieces that I'm missing is going to be negative 3 squared. But notice this negative 3 is not just being squared. It's also being multiplied by 2. So I got to multiply this by 2 as well. All right? Once you factor out that leading term, you got to complete the square afterwards. So you don't start off with completing the square, excuse me. Then I get negative 3 squared, that's positive 9. 9 times 2 is 18. Put the negative under, that's minus 18. Follow your rules of operations. All right? Negative 18 plus 13 is negative 5. So you get this expression right here. This is your vertex form, which means your vertex is located at positive 3 and negative 5. It has a minimum value of negative 5 because this is a positive multiplication. If it was negative, it would be a maximum. All right. Now, if you want to calculate using that formula I gave you, f of negative b over 2a, negative b, well, your b value is negative 12. So you got negative of negative 12 times 2. Your a value here is 2. So plug that in. Then boom. Where is it at? I lost it. Boom. And then we get, if we calculate all this, negative times a negative is a positive. 12 divided by 4 is 3. F of 3. This is the x value of the vertex. Now to calculate the y value of the vertex, we plug this 3 in for our output. So boom, boom, boom. Calculate this all. We get negative 5. Our minimum value is at negative 5 because the a value is bigger than 0. Remember, this a value right here is the same a value as over here. These two are the exact same a values. Okay? So we still have a minimum at the end of the day. So you can choose which one you prefer. Now on test, I might ask you to complete this square to see if you can use it. Over here, boom. That's another example. I complete the square here. This time this is a negative 2, so I factor out a negative 2. If I factor out a negative 2, I get x squared. Instead of positive 4x, this becomes negative 2x because I'm dividing it by negative 2. Boom, boom, boom. And then when I multiply this negative 1, I have to do negative 1 squared. And I have to multiply by this negative 2. Boom. So then I get plus 2 minus 5 if I did all of my algebra. I get minus 3. The vertex is located at 1, comma, negative 3. We have a maximum value of negative 3 because this is negative. Okay? If you want to see applications and modeling problems, please refer to your book in page 3.1 or section 3.1 in your ebook. Those are going to be very important because you're going to be required to do projectile motion problems. I would suggest you take a read on that. That's it for today. I will catch you guys later. Take care. Bye.